Hello and welcome to Metra Home Theater Tech Tips. I'm Brent.
I'm Adam.
And Adam, tell me what we got going together this week.
Well, we are now on to episode 3 of our multi-part series where we're talking about the basics of networking. Three? Depends on which.
I can't do that anymore. I'm old, arthritic.
Yeah.
So I can.
Well,
I can do that.
That's a there you go. That's a movie reference.
No. That's a movie reference.
Well, that's a TV show reference. Anyways, what we're talking about today, of course, is we are continuing our multi-part series on the basics of networking. Today is
this Amway?
This is sure. This is part 3 where we're talking about networking equipment or gear, or what was the word that you had used? Equipment. I said equipment.
Hardware?
Hardware, that's a better word for it. Networking hardware. So what we're going to be talking about today, of course, is networking hardware, what it is, when to use it, how to use it, what do you really need, what is kind of an extravagant portion that you don't really need, but is still something to add to it. Of course, as always, thank you for checking in with us today. If you have questions or chats or anything else that you want to talk about, put it over here in the chat section. If you're viewing this after the fact, you can put it down in the comments below. Now, of course, Brent, we have a special thing going on that anybody who is watching the episodes with us and has subscribed, we are giving away a 4-channel NVR kit. So this is a 4-channel NVR kit. Yes, it is.
4-channel NVR kit?
4-channel. Yep. Not 4-channel.
3.
No. 4-channel. There you go.
4.
This is the 4-channel NVR kit. It's a 4K kit. Right now, the way to win it, of course, is to watch these episodes. At the end of this series, we'll be picking a winner. You have an opportunity to put your name in the drawings.
With comments,
what you have to do
questions.
Is leave a comment on these videos. Every time you leave a comment on a new video, you get put in for another chance to win. Now, that's one chance per video, but come back, watch the videos, make sure you're subscribed, make sure you hit the bell notification to let you know when we are going to go live with a new video, which of course is every Wednesday at 3 p.m.
All right. Now tell all your friends to subscribe and you can use their name.
Yeah.
Not that we ever encourage anything slightly underhanded.
Trying to cheat the system, Brent.
Just a little bit. So, with that said, what we're talking about today is, of course, networking equipment. Primarily, we're going to be talking about, you're in a nice little piece, types of networking gear. Now, when we're talking about networking gear, there's a couple things that we need to understand, like what is this, what is that, what's that thing, what's the thing that gives me Wi-Fi, what's the thing that handles and makes sure that I get an IP address, which last week we talked about was DHCP. Well,
and a little bit about static, but yes.
Yeah, and a little bit about static. So, with that said, Brent, what device normally in a standard consumer or residential location, what device is the thing that has DHCP?
Well, DHCP will be handled typically through the router,
right?
Which in most residential applications is usually built in to the modem because they get it from the cable company.
Right.
They plug in one piece, they sign on their Wi-Fi, and they may have one device plugged into the LAN port or not.
Yeah. So there's multiple types of gear for when it comes to networking equipment. The best way to kind of go through those pieces is actually to start at the wall. And I say start at the wall because that's a good starting point. The wire that comes in from the wall, whether it be a coax connection, a phone connection, or nowadays a fiber connection, right?
Some people in the 10G land, lucky them.
Yeah, right. Up, getting in those awesome speeds with that. So when we look at the different types of equipment, let's go ahead and start at the wall. I'm going to switch over here to the top shot, and we'll go ahead and give us one of these deals. Okay, so.
I should have brought a modem in today.
You should have brought a modem in today. I should have reminded you for that. So we'll start with at the wall. By the way, everybody, if you have other devices that maybe I've missed in some of this, go ahead and leave it over in the comments or in the chat section as well. So when we look at, here's the wall, of course, and we've got our connection that comes in from the wall. Right now, we're going to go ahead and do the trusty cable connection. We're going to do a coax connection. Coax connection comes in from the wall. First thing that it's going to hit is the modem, right? We're going back to basics with this. So the modem device, of course, and you'll see lots of different brands and models and everything else. There's Motorola makes a modem that you can buy. Aris, UB, I think there's a couple others out there as well. Samsung, I think, even makes a Pace makes one. Yep. So the modem, of course, that's going to take the connection from either coax, or if it's a phone connection for DSL, or it'll take in the fiber connection if it's a fiber, service feed at that point. And what it's going to do is it's going to give you connection. It's going to make sure that the outside world, it's basically a tuner in so many ways. That's one way to kind of describe it. So it comes into the modem. The modem then converts it from one of these connections here down to a category wire. So we go out from there, we go into a category wire.
And what is that port named?
This is your WAN port. Or actually, well, that depends. It depends on where it's going, because technically at this point we are at our LAN because we are now inside the network.
Most modems will have two ports, a WAN and a LAN.
Sure.
So you can go from the modem in a bridge mode out the WAN into
Correct,
another
yeah.
switch, or out the LAN if you're using the internal router.
Right. So across our category wire, which will be either a Cat 5 or a Cat 6, depending on what's going on, we'll go into our router. Now, the router is something like this Netgear that I have here on the table with us here. The router itself, this is what is handling the routing. That's why it's called a router. It routes the signals from outside, from the WAN connection. So this is out here in the cloud. At that point, this is our WAN connection out here. And it comes in like that. It's the thing that's actually making sure that all of the other devices that are on the network can work their way through all of this and get the data from outside to inside and make sure it's going to where it's supposed to go. It also helps inside the network to make sure that, again, information is passing from one device to another correctly, right? It makes sure that, hey, I've got a computer over there and I want it to talk to a device on this side, and it's going to be able to route all of that and make sure that it communicates correctly, right?
So the router is the one establishing addresses.
Correct. It's also the one that's routing the communications.
And controlling who gets what and where.
Correct. Yeah. Now there's a lot of other things on top of that. There's IGMP. There's some of the other standards that they use for like the MOIP systems or the video over IP systems or voice over IP systems. There's other things that inside of that traffic that happens with it, which is beyond what we're going to talk about today. But what happens with all of this, of course, is that it comes into the router. So the router is kind of like a good way to describe it, it's kind of like the brainstem at that point, because you've got the rest of the equipment in the house or on the job site or whatever, and they all go back to the brainstem, which is then talking to, well, we'll call the brain the cloud at that point. And the brainstem is making sure that everything is routed to where it's supposed to go.
You love that word, routed.
Routing, well, because that's what it's doing. It's routing, right? Yeah. So that's what the router is going to do. So the router is going to take all the information in from the outside world, and it's going to make sure that it goes wherever it's supposed to go. So here's what normally happens. When you get on your laptop or your computer or whatever, and you go to a website, let's use Facebook as an example, or YouTube. Again, everybody who's watching, thank you for checking in. Leave your comments over, or leave your chat comments over in the chat section, or if you're watching after the fact, you can leave it down in the comment section below. Remember also that in order to be put in for the winnings for the 4-channel kit, we do need to make sure that you leave us a comment on the video. So, what happens then is if I go, I'm then going out to the router and I'm saying, hey router, I want to connect to youtube.com. Router then goes out to the DNS server, which the DNS, that's going to be an entirely other episode. I think that might be, I don't know if that's next episode or the episode afterwards, but it goes to the DNS, then takes that youtube.com, and it has an address list inside of it, where it's going to send that traffic to the IP address for YouTube, right? So from there, it goes out to YouTube. Now, there's packets of information in there that say where that request came from. So that request...
Wait, they're tracking me?
Yes. Yes, it's too late. You're already being tracked. So, you for other reasons, though. I don't know what you've been doing. That's anyways. So, we're going out to YouTube, and in that information that's being sent out, what's happening is it's saying where it has come from. It's come from this IP address, and on the LAN, also the WAN. So that, remember, we talked about the difference between the LAN and WAN a couple episodes ago. So inside that IP address information, or that request, is where it needs to be sent back. So what happens then is it goes out to where it's supposed to go onto YouTube, then it comes back in from YouTube with all the pertinent information, the stream or whatever it may be. Buffering problems. Uh-oh. We're having network troubles.
Lucky us.
We'll keep recording. So as we leave and we go out to, as it's coming back in, it comes into, of course, the service provider's service connection, and they'll handle their part of it, which they also have a version of this. They have a router of some kind on there, and it's a much more capable router than what we would see on the residential side of things. However, they have essentially the same thing. It's then saying, okay, well, I need to route that traffic back to where it came from. So it goes to your WAN connection, which could be any series of numbers. Then from there, it gets to the router. The router then says, okay, well, that traffic, the return address for that traffic is this particular IP address on the LAN. So it is then making sure that that traffic goes back to that device. And that's essentially the route that it takes from that point.
So much like the post office,
Yeah.
this is my house.
Yes.
This is the post office.
Yeah.
It knows when I send a letter out and when I want a letter back.
Yep.
It all goes where it's got to go.
And with that post office, again, the post office also has other distribution centers as well to get to other areas where it needs to go to as well.
As quickly as possible.
As quickly as possible. And so that's kind of how that works out, because it knows, okay, I've got the address that it's going to, and I have my return address that I need to get back to. So from there, that's essentially what the router does. So we'll notice a couple things here. If you look at the top of this thing, go ahead and cut back over here to this. If you notice the top of, or the back of the router, we only have 4 LAN ports. Now, Brent, in your house, we'll use your house as an example. How many internet connected devices do you have?
Follows up a conversation you and I were having prior to the broadcast
Exactly,
today.
yeah.
In my rack, I have my TV Cube from Amazon, which has a network connection.
Yep.
I have my AVR, which has a network connection. I have my UHD Blu-ray player, which has a hard network connection.
Are you keeping track? What are we up to, 5 or 6?
I'm up to 4 so far.
You're up to 4, okay.
I have my Apple TV 4K, which has a network connection. I have my Smart Hub, which has a physical network connection.
Right.
I have my Crestron CP2E, which has a physical network connection.
Yep.
Now, that's just hardwired in the rack.
Yeah.
I also have my Sony television, my LG television, my Amazon Fire Stick in the living room, Amazon Fire Stick in the bedroom, which are Wi-Fi, my PC laptop that's Windows 10, my PC laptop that's Windows 7, and my Mac laptop. I have lost count.
Yeah.
Now, this is what I can recall. 5-inch Amazons, 5-inch Amazon on the desk, 8-inch Amazon on the kitchen counter, 2 Echoes, and a little coffee cup warmer looking one for my music.
Right.
Oh, and my 2 Sonoses.
Yeah. Yeah.
Wow.
So you've got quite a few devices
But
connected.
that's why it fills up when I thing it.
Well, the thing is that a lot of that, all of those things are devices that need internet access, or at the very least, network access.
Yes.
And most routers that you find nowadays are going to have roughly 4 connections on the back of them. That's kind of like, and even into something of a more high-end system like the Luxel systems or PackEdge or whoever else is out there. These systems here also have about 4, this one actually has 5 connections on the back of it. Now it does have 2 WAN connections. That's a nice little feature on some of these, the higher end units where they dual stream out of it or into it. It's usually not worth it to do that because usually you run into other problems. The cost for one, it just doesn't seem worth it, but also you run into bandwidth. It's not bandwidth problems, it's more like just relinking that connection on the other side. Usually not worth it unless you're in like high-end data centers.
Where you got to have redundancy.
Right, which this is not meant for those, this instruction or this video is not meant for those people. There you go, perfect. So guys, again, thank you for checking in with us. If you are having streaming, we are having streaming problems right now, which it's a perfect episode to be talking about networking for us to have streaming problems.
As was our very first episode.
Exactly. But we will be re-uploading this video afterwards, so definitely same thing applies for that. Leave us a comment, leave us on that video so that you can be put in for the runnings for the 4-channel NVR, which we will be pulling those drawings at the end of this series, which I think we have another 2 or 3 episodes or 3 or 4 episodes. But we'll find out at that point. So anyways, Brent, we only have 4 connections, 4 physical connections on these devices. What do we do? How do we, I mean, can I just take a wire and twist the green pair together and twist the orange pair together?
Well, as best I can tell, according to
that?
some of the consumer forums online,
right?
You can.
Sure.
Well, beanium, little wire nuts.
Little beanie caps or whatever, right?
They do it for HDMI, right?
Yeah, of course, right?
Yeah.
That's all it is. I mean, an HDMI splitter is just inside. It's just soldered connections that wire off in there. There's no extra processing.
It comes down to you need to start looking at your bandwidth requirements. Can you Wi-Fi it, or do you need to hardwire it?
Yeah.
And kind of back to the conversation you and I were having before the show.
Yeah.
Because we do take a different approach.
Yes.
On non-controlled, IP-controlled products like televisions, hardwire because with some manufacturers, as you noted quite eloquently, they don't always wake up on Wi-Fi.
No, they don't. And in fact, that's because they're using services like Wake on LAN, which most of those services require a hard line connection because it's an actual voltage that hit to it that's triggering it to wake up. And whereas Wi-Fi, of course, if it goes to sleep, it goes to sleep.
Now, if we were doing that kind of job, let's be honest, we're not putting this in.
No, something like that. We're definitely putting it in something like the Luxel system. Now, on a job like that, also, I need more than those 5 physical connections. I need a lot more.
You might have video surveillance that's hardwired.
Yes, or I need PoE or something else. So that's where the network switch comes in. So with the network switch, all it really is doing, in the most basic of terms, it's taking the signal from the router. It's doing a lot more than that because, again, everything is addressed as we're using IP addresses, MAC addresses, whether it be IPv4, which in 99.99999% of the jobs that you're going to run into are using IPv4. If it's using IPv6, again, we're going to have an episode on that, but that's going to be a little bit later on because there is so much information when it comes to that, but we'll talk about it
just
at
in
that
the
time.
address, there's so much information.
Oh gosh, there's so much information. So when you look at a switch, what's happening then is it's taking in the signal from the router. The router is then saying, okay, here's all the information, here's all the connections, and the switch is then taking that information and routing it again to who it's supposed to go to. Now the difference is, of course, is that the switch has a different table inside of it that's not...
It's not generating addresses, it's only connecting addresses.
Correct, but it does a couple other things with it as well, depending on whether it's a smart switch, something like this here, where you can actually log into the switch and do certain routing capabilities, whether it be VPN or other services like that. Or it has its own table inside of it to know, okay, port number 23 is connected to the TV, port number 26 is connected to a surveillance system. For that. Yeah, it's able to prioritize it. Now, so that's our physical connections. Now, our wireless connections are different, right?
What if we have a managed system?
A managed system.
Where if you're moving from one zone to another, is that another episode?
Yes, that's going to be our Wi-Fi episode.
Okay.
Yeah, we're going to do an entire episode on Wi-Fi because that's an entire. There's a lot of stuff when it comes to Wi-Fi, managed, unmanaged, VLANing on Wi-Fi, Wi-Fi signal itself, and how difficult it is for it to work correctly. What I have over here, and the wire is too short, but on top of the rack back here, I actually have our wireless access point that we use here in the lab. It's in a really bad spot. It's not mounted correctly. It's not...
Like many things around here, we find out how bad we can make it work.
How bad? Yeah, exactly. We make it bad. So with that connection, what a Wi-Fi access point is, and in many cases, again, when we talk about the residential applications, a lot of times it's built in to the router. One unit. It's just one unit. The modem, router, Wi-Fi combo piece.
May have antennas on it, but...
Yeah, sometimes it has antennas on it. Like this one does not have antennas. Everything's built in internally. Did you drop this?
You know, that one has lived a life, okay?
You want to see inside of it, huh? I kind of want to see inside of it.
It's just lived a life.
You want to see inside of it? Anyways, moving on. So, with this piece here, the Wi-Fi, the router, the Wi-Fi,
which generally
all built
is provided
into it,
by your cable company.
Which is generally provided by your service provider. Now, in that case, there's a lot of stuff happening inside of that one piece. Now, when it comes to systems, depending on how advanced you need to go, that may be all you need. In a lot of applications, maybe the residence is small enough to where the Wi-Fi coverage, you don't need extra access points to do that. It may be at that point it's a small condo or something like that where you don't have to worry about too many connections.
We've all started that way.
Right.
We all started with either one provided by the cable company, or we went down to your local big box retailer and we bought a product like that plugged into the modem. And most of us have gone well beyond that, not because there's a lot of us living in the house.
Right.
But simply because it's amazing how many devices wind up sitting on your clothesline as a surprise.
Yeah.
I mean, just going down my list earlier, it's like, holy cow, do I have a lot of stuff in there.
Well, and some of the things that you said Fing before on iPhone and Android, we use it for finding out if finding out what devices are on the network. In fact, I used it earlier today because we got a new power switch that we're working with that's connected to Wi-Fi. It's a piece that we use here for the broadcast. I had to find it on the network, so I just went ahead and installed
Finged it
Fing. Yeah, finged it out, right? Found it on the network and was able to work with it from there. So Fing is a really great app for consumers, for integrators, for whoever else. You can download it onto your phone, do a scan. It'll show you all the devices that are on your network, on your subnet.
And the one that we use most around here on the phone, Angry IP, or what was the other one you guys use?
Advanced IP Scanner is the one that I like to use on Windows devices. On Mac devices, Angry IP Scanner is another really good one as well. But on mobile devices, Fing is really great. I highly recommend it for integrators that are out there. Anything with networking. There's also another tool that you can use, and we'll talk about it on the Wi-Fi episode, but it's a Wi-Fi analyzer. If you want to look professional, pulling out your phone and telling the client, hey, you've got this many Wi-Fi connections in your area that you're competing with, you will look like a hero at that point, because you're showing them on the screen of the phone right there how much they're competing with and why their Wi-Fi is terrible at that point. So then at that point you can tell them, look, hey, let's go ahead and put it in a nice Wi-Fi system.
Something that's meshed. And
something that's meshed, and something or it's something that's a dedicated system that's hardwired, has multiple access points. You can go ahead and have a stronger signal in your area, so you don't have to compete with other people.
Speaking of hardware, what's a WAP?
It's not the song.
And I did not even know that existed until I saw it on YouTube the other day where she was talking.
Anyways, moving on. So a wireless access point. To get to that, Brandon.
Honestly, I had no idea that was a song.
So a wireless access point is basically a switch, but for Wi-Fi. And that's basically what the Wi-Fi is that's in these all-in-one router systems that has the Wi-Fi there. It's basically just a switch. It's additional connection points for devices. That's all. It's basically the same as that device. Now, it allows many more connections than most for switches, whereas with Wi-Fi, it's a wireless signal. It's pretty easy to do. You have limitations because you've got bandwidth and communication, traffic, and everything else that's going on with it.
Headroom and additional commands and...
FWT is saying the current technical difficulties would be a great webinar subject. You are not wrong.
And by the way, it was in fact one of our very first webinar subjects, because the very first live broadcast we ever did, a minute before we went live, Facebook went down.
Yeah, Facebook went down because our first episodes we were live on Facebook instead.
And didn't know.
Yep.
And
the very first one.
We died right out of the gate.
Yep, right. And 10 minutes before we went live, Facebook died. It was great. Anyway, so you are correct. We should do an episode on that. I think that would be a lot of fun. So those
are glitchy.
Yeah, right. So when we are dealing with the different devices, we have, of course, we're coming from the wall. We've got the modem, the router, the switch, or the Wi-Fi, depending on, or the Wi-Fi access point. Those are kind of one and the same kind of a thing in most of these routers. This also includes the high-end routers like the Luxel systems. This would be the firewall. That's one of the main things with it as well.
Now, and obviously good systems have standalone firewalls that are incredibly configurable. Mm-hmm. And if you're doing anything worth a darn for your customer, putting in a separate firewall to protect their products, their integrity, their security is a good idea.
Yeah. Now, and especially if you needed added extra security for it, most of the firewall systems that are built into these routers are really good. But if you do need added security to it, those dedicated firewall systems usually give you added security features. Also, because they're specifically a firewall, it kind of becomes that all-in-one problem where you may get a printer, scanner, fax machine, copier, all that stuff is in one device, and it does all of those things pretty well. Okay, but if you were to get a dedicated printer, something that like a high-end printer, you go to the printer to print for you. It's quicker over there if it's a standalone, better quality prints, all that kind of stuff.
More print copies.
More print copies, whatever it may be. So the standalone device is usually better quality. It's just a better device overall. So that's kind of where the all-in-one pieces, that's where we run into troubles with it, especially when it comes to ISPs. Let's be honest, ISPs are finding the lowest bid possible for their devices. Because in most cases, they are giving it to you for free. It's not really free. You're paying for it because they put it on your bill and all that nonsense and stuff. But they don't. If you cancel your service, they don't want to have to pay for that device. And so they go for the lowest bid possible in order for that device to work. And that's it. So that's why, again, if you can, do an upgrade. Go out to, Best Buy, anybody else out there, the distributors out there as well have networking equipment available. Definitely track one down that's aftermarket, something like that, because even just the entry-level aftermarket systems are light years beyond what service providers are giving out. So those are kind of the devices that we're talking about. We're already at 30 minutes just talking about that. There's a lot of other things with that. So we're going to move on, and the next thing that we're going to talk about is what are the types of networking gear. Hit this button to make it work right. What are the types of networking gear? So we already kind of went over that, all these different devices here for that. So we're going to go on to the next one.
Wait, don't forget the most important part of your network gear.
Infrastructure. And actually, we had a discussion, we had a training this morning with a dealer group that was actually really informative, because we talk about HD-base-T to get HDMI signal across an HDB connection must be just
really good.
Really good. Really, really good. Now, HD-base-T does a pretty good job making sure that OK connections work, but having a really good infrastructure, and by infrastructure we mean, of course, the actual category wire that's in the wall.
The quality of the wire, the quality of the windings, but most importantly for you guys in the field, the quality of the termination.
Yes, 100%. And what we mean by that is, of course, when you go to terminate, don't use the EZ45s, the pass-through style terminations. Don't use certain other brands and stuff.
You're welcome to call us and we'll share that information on the phone with you.
Yes. Now, what happens with those, of course, there's other brands out there. Don't use the pass-through style. Make sure that the terminations, the actual insides of them, that the wire, when it goes into it, is the correct sizing. If it's oversized, what will happen is it won't crimp correctly. You'll get bad connections. It's not worth it.
Make sure all the wires are fully inserted. It is not uncommon for people to blame the network. If a network's slow, this is slow. Honestly, the vast majority of these problems are caused by termination errors. And you guys have all heard, well, I've been terminating cables for 25 years, or everything checks out fine on my Fluke. Yeah. What does it cost to get a Fluke that's actually going to give you bandwidth testing that's worth a darn?
Roughly $10,000 to $15,000.
About 15.
Okay. So, and what he's talking about, of course, that was a 10 gig Fluke.
10 gig's already outdated.
Exactly. You're designing these systems not only for 1 gig, but also for greater than that in the future. So, what we're talking about, of course, is checking for or certifying those connections. You can get a Fluke tester for $20, $30, something like that.
I think $100
for a decent one anyways.
Yeah.
What that will do is you'll have a connection on one end of the cable. You put your tester on the other side of the cable. It's going to make sure that you have continuity. You don't have anything crossing. You have all your pins in the right order.
8568A or B.
Yep. It tells you all that stuff.
That's what it tells you.
And it tells you the distance.
And as you go up in process, it will tell you the distance, and it may allow you to stick ID numbers on each of the ports.
Yeah.
So you can say, okay, port number 19 goes to the kids' room, port number 20 goes to the master bedroom, and you do want to map out all of your locations.
Right.
Because when you go to plug in the switch, it's good to know what all those cables are.
And label.
Don't cut them too short, and label them.
Should we add that to? Man, the end of our webinar is going to get a little bit longer, right? So when Brent's right, one of the most important things, other than the equipment itself, is the infrastructure.
Actually,
make sure
in my opinion,
it's even more important.
It's more important because you can change equipment.
This is true.
If your infrastructure's not there, I don't care what you do with the equipment.
Right.
It's still not going to work right.
Yeah, exactly. So now, let's see if I got the right one. Did we go to the right one? There we go. What gear do you really need? Right?
Really good termination tools?
Well, yeah, really good termination tools. So when we're talking about gear, and of course I'm not just talking about it goes along with that. So what pieces do you actually need? And let's talk about equipment first, and then we'll talk about tools. To be honest, it depends on the job. And that's usually the answer for everything,
by the
right?
way, Adam and I have done a number of jobs together, and networking's not always the same from job to job. And in some cases, we've completely ripped out network systems and changed the hardware based on what we thought we knew going in and what we learned on the job.
Right. Yeah.
And don't be a brand whore.
No.
Open yourself up to other options, because I can promise you, what's hot.
Let's get bought out by other companies and it changes their quality, or maybe their QC changes, or their
feature sets,
whoever it is, feature sets changes, and however that happens. To be honest, it's one of those things where it's you need to go ahead and put your
training
immerse yourself into the equipment, try it out, use it in your own house. for a little bit. Use it in your own office for a little bit. Find out how well it works. Find out its little kinks and
Talk to other
features and stuff.
integrators if you don't use it for this.
So when you break it all the way down, the only pieces that you really absolutely need, it varies from job to job, but let's say at the most basic, your 2-bedroom house that they're not doing anything special. They've got maybe a Ring doorbell and a couple Alexa devices here and there. So what do they really need in that application? They need the modem, they need the router, and they need Wi-Fi. That's it. That's all that they really need.
And it could be on one piece. However, as soon as you throw the Ring camera in there, you pretty much need to walk away from the modem from the cable company.
Yeah, and at that point, you need to make sure that, because of, again, it comes down to Wi-Fi, because you may be limited on where you can put that modem, that all-in-one modem piece, because they only have a cable connection over here, they only have a modem or a phone connection over there, or especially with fiber, usually there's only one location in the entire house that you have a fiber connection. And so a lot of times that's inside of a panel somewhere else, which will
kill the Wi-Fi.
Which will kill the Wi-Fi unless it's plastic. So again, it varies. It depends on what's going on in that job. So there's no one thing to say that every single job that I do gets this, this, and this, period. Well, what if, I mean, look, if you have a 2-bedroom condo, do you need 48 ports on a network switch? Maybe. I mean, how many devices do you have? Do you have 12 devices per room in that case that need to be hardlined into it? Possibly. It depends on what's going on there. So in those applications, you need to look at what's necessary for the job and give yourself some headroom, because as we know, clients like to add things here and there. Oh, by the way, can you add this? Can you do that? Oh, I got this new thing. A friend gifted this to me. I'd like to add it into the system.
Did an upgrade on a Wi-Fi system recently, where I put the little Google triple set in, which was a nice little package for $199, $249, whatever it was. But I also had some Crestron gear and a Sonos piece that I wanted hardwired. Well, there's no LAN jacks. There's only a WAN jack on the...
Yeah.
So I had to go out and buy a little 5-port switch.
Yeah.
Now, a 5-port switch is $49. Tie the Crestron touch panel in and tie the Crestron processor in, and then tie the Sonos. Sonos was Wi-Fi, so just the Crestron, because I had to route those addresses.
Right.
But without those additional ports, the Crestron's dead in the water.
Yeah. Yeah, exactly. It can talk to itself maybe, but that's not it.
I don't do that because
there's
without
no
the
good
router,
there.
it didn't know the address of the touch panel.
See, there you go. It can't even do that. So again, it varies on the job. So make sure, again, it comes down to design. Make sure that you're understanding fully that, look, sometimes installing a simple TV, 5 speakers, cable box, Roku, gaming system, and one other device
and
in
a
there.
ring. You beyond
just AV. It could push you very easily into networking equipment, especially if we're talking about surveillance. Let's discuss that a little bit. As soon as you start adding in surveillance systems, whether it be a traditional AHD system that's using coax, your NVR needs a hardline connection for network connection to be able to be viewed through the cloud or remotely. And if we get into,
we are already to 16 camera IP systems.
Yeah.
So you got the 16 plugs there. Then you got the network cable going into the NVR. So that's 17.
Yep.
Then you've got your router. We haven't even tapped on all the other ancillary devices. The TVs, the AV, the printers.
Which a lot of those devices should be hardwired into it. Now, so it's very easy to get into, hey, now we're moving into needing to actually be networking professionals. We need to understand IP network connections, make sure that we have everything routing the way that it's supposed to go. Make sure the tables are set up correctly. Make sure that we can connect to the devices that we need to connect to. Nowadays, AVRs, in some cases, don't have all the menu options on the on-screen. They have extra menu options only available through the network.
And it's a whole lot easier to set up most AVRs.
Yes.
Most AVRs via IP than it is on the on-screen.
And a benefit to all of that as well is that if you're designing systems and you're setting them up and tuning them specifically to those spaces, you don't want to lose all that tuning. So you can log into those devices and back up your configuration files.
And control them remotely.
And control them remotely. So what you're doing when you're designing systems, make sure you're taking into account the networking setup for the systems. Some clients network, you need to explain to them that you need to make sure that their network is sufficient for what you're trying to do.
And most of them think a $49 piece from a retailer is more than sufficient.
Most of them are going to think that their ISP supplied modem router Wi-Fi combo piece is perfectly fine for what they want to do. In most cases, it's not, unfortunately. And so in those cases, you just convince them that, no, it's time to do an upgrade of some kind. So definitely watch out for that stuff. So
now, while we're on hardware,
yeah,
let's talk about one of my favorite topics, grounding.
Ah.
Now, I had a conversation with a dealer yesterday working on a large home, and they're doing control of the televisions via IP. And they're also sending out audio and touch panels and all this stuff over IP. Now, what this really means is you need to have the televisions, all the network access points, everything, the Romex pulled back to the master equipment location.
Yep.
You don't want to have this on multiple panels around the house. You don't want to have this on different sides of your circuit breaker.
Right.
You want everything pulled back because any one of these that's not tied to the same circuits or group of circuits or side of the panel can throw out ground potential issues. And networking picks that up and amplifies it.
Yes, very much so.
So there is a reason these are 3-prong plugs.
Yep. Yep. In most cases, they're 3-prong plugs. You get in the smaller ones, this is just a 2-prong.
Yeah, well, it's low voltage going into it.
Exactly. So, yes, very much so. Grounding, and again, you see that come into play in almost everything that we do. When
Absolutely. The AV world, networking world, controlling the power on becomes paramount. And this can be a little bit tricky with the electricians and the homeowner. But if you can pull the power to the TV, to the WAPs, to all the devices back to the central point, so they're on a shared circuit or panel, your problems diminish greatly.
Greatly. Very, very much so. Yeah.
We fight that here because everything in here has just been hodgepodge together through the years, and we have no idea where some stuff is even powered by.
I think we've fried quite a few devices a couple times ourselves anyways. Now, and again, this is one of those do as we say, not as we do. Reminder, everybody, comment on today's video, comment on the other networking videos for what we have going on for a chance to win the 4-channel NVR kit from SpyClops Pro. We're really excited about this.
Which has a great app.
Yeah, and it's 4K, by the way, 4K cameras, which are, it's really great. I like
that's a hardwired kit.
It is a hardwired kit.
Now, is that hardwired into the NVR, or is it hardwired into a PoE switch?
So here's what we found out. Both. You can do that with both. So these cameras, it's designed to be used as a standalone system where you just plug the cameras directly into the NVR.
Up to 4 of them.
Up to 4. And then from there, you're good to go. All the cameras show up, everything's good to go. It's as if it's an old analog-based system. But we've also found out the cameras that are included with this, if you need those cameras to be somewhere else, you just need a PoE switch. You can add those kit cameras to a standard PoE switch to the system. Or this system is expandable all the way up to 16 cameras. So we have 4 cameras included, so you've already got 4 to go. You can add 12 more cameras to it and have a total of 16 cameras.
So if you add a PoE switch,
you
can buy more cameras, plug it in, and it's no longer just 4.
Right. Becomes as many as you need up to 16.
Up to 16.
Yep. So that's the gear that you need. Now, do you need wireless access points? Again, it depends on the job. But in most cases, no, you can use just the built-in Wi-Fi or have a single access point.
There's one more thing I think you should add to that. UPS.
Ooh, yes.
Because here's the reason why, guys. Just because the power's out at your house doesn't mean power's out on the modem or on the internet provider.
Right.
If you can keep the basic modem and Wi-Fi going on a UPS, they've still got news, they've still got their connectivity, they've still got their communication.
Yep.
Even if the rest of the house is out.
Yeah, most of those systems are on either generator or battery backups already. And so in those cases, if you, and this is good for anybody who's dealing with power outages because of inclement weather. Down here, of course, in Florida, we have, hurricanes and big storms to deal with.
Rain every afternoon at 3 o'clock.
Yep. Up in the Northeast or in Midwest, you get snowstorms and ice storms. You get, tornadoes. If the weather causes your power to go out, have a UPS, because at that point, you can still use the internet access, find out what's going on in the news, find out when power's supposed to come back. But a UPS will give you just a little bit more time with that. And in some cases, depending on how many devices you have connected to it, it could last for a decent amount of time. It's also useful in many cases as a surge protector as well. Brownouts are things that cause more damage than overcharges at that point, and definitely something to watch out for. So that's that part of it.
That's that. What else is there today?
The last little last little bit, how do we fix network equipment problems? Well, don't
Big
call
hammer?
me. Don't call me.
Big hammer.
Big hammer. No, honestly, when it comes to network equipment and how to fix network equipment problems, you fall back to the traditional troubleshooting process. We start from one end and work our way down to the other side.
First thing you do is make sure you got power to it. And
Yeah.
don't laugh about this one.
This is true. If you look at some of the standalone pieces that have the router and the Wi-Fi built into them, they're using just a normal DC barrel connector. And at that point, sometimes that DC barrel connector can come loose just a little bit to where we have
Particularly
just
if
enough.
you've been working in the rack and it's nicely tied down, but you've moved that box a little bit.
Just a little bit, and you lose connection. So check that. Make sure you've got power is turned on to it. Double check that your because here's the thing: when you have a here's one right here.
While he's looking, also get to know your local ISP provider's trouble page. Most of them will provide a bar graph on connectivity in your area. It will save your life with your customer when they have no internet, and you can pull that up and say, yes, sir, and your zip code right now, there's a problem.
Yep, other people
And
are having the same
I use
problem.
the heck out of that.
Yep. So it's to find out whether or not, hey, if one client's having a problem but no one else is, you got a good idea. You might need to roll a truck. If you've got one person calls you up and says, hey, my internet's out, and they say, yeah, everyone else in your area is also out, you don't need to roll a truck because, hey, it's not your problem.
You just need to wait.
Yep, just got to wait. So when you are troubleshooting different things, make sure that your connections are good and solid, for one.
Test them on occasion.
Test them on occasion every once in a while. If you're running, well, most of the time you're going to find out if there's a problem with it.
Well,
but
on your kit, this is, again, not a joke. You plug this thing in several times, in and out several times, it may lose connectivity.
yeah.
Because they are not meant to go in and out, in and out, in and out, in and out. It's
Right.
meant to connect and walk away.
Yeah, leave it there.
So don't keep using the same test that you've been using for a long time.
For your own troubleshooting kit, that's what he's talking about. If for your own troubleshooting kit, you're more than likely to have like an Ethernet cable in your truck that is specifically used to plug in your laptop to the network when you get there to try something. Double check that wire is still good, and every so often replace it or cut the ends off and put a new end on it. Some of the other things also, and we've all run into this, I'm sure, on the RJ45 termination, you have the little pin or little